In 2024, Keytruda was the best-selling drug in the world. That's right, beating the likes of Ozempic by nearly $13 billion. Some have it projected to go on to be the greatest selling drug of all time, with some projections in 2026 showing revenue in the $30 billion range. It's been called a miracle drug, a new start in oncology research, and paving the way forward in the fight against the world's deadliest diseases. But how did we actually get here? You would think a treatment of such ultimate innovation came with the likes of the most brilliant minds working in a top secret lab with an unlimited budget. But the story behind Keytruda is actually quite the opposite. It was a series of dominoes that fell in the weirdest, most unlikely way possible. It was one of the craziest stories I've ever read, and it's one I bet you didn't know.
All right, let's get started, shall we? So, let's talk about cancer. It's been heralded as death itself, an irreversible curse, or just the end. Despite this message trickling and flowing through time, medications, treatments, and advancements in science have always been made. Not all have given up hope on this deadly disease, this champion of death, and we would see examples through time that would prove that true. The term cancer was birthed by Hippocrates in around 460 to 370 BC. Today, he's known as the, quote, father of medicine for his many contributions to the medical field. One of these was he was one of the first to take a physical approach to medicine rather than a spiritual, as it was kind of common practice at the time that medicine and diseases were seen as divine justice from the gods. In some of Hippocrates' research, he observed finger-like projections on unhealthy bodily components that he said were reminiscent of crabs. So he aptly named these unhealthy tissue after crabs. The Greek term carcinos actually means crabs. It was then changed from carcinos to cancer in around 25 to 50 BC by another Greek physician named Celsus. However, what Hippocrates got wrong was the cause of cancer. See, Hippocrates believed that well-being in the body came from a balance of 4 substances: blood, phlegm, yellow bile, and black bile. He called these the 4 humors. He believed that blood was blood, carried oxygen throughout the body, phlegm was a mucus in the lungs that killed pathogens, yellow bile was in the liver, and it was important to digestion, and he believed black bile, which if you had an excess of too much of, caused cancer, which turned out to be wrong. Father of medicine what? Father of medicine who? Father of mid?
Oh my goodness, Valentine! No. Whoa, no!
Anyways, modern medicine has shown us that cancer can be caused by a number of factors. It can be genetic, can be caused by your environment, like smoking or radiation, and sometimes just an unhealthy lifestyle can lead to the development of cancer. But we're not there yet, so 2 seconds, I promise. Hundreds of years after Hippocrates made his own discoveries on cancer, Claudius Galen, another Greek physician, put forward his own developments on the theories that Hippocrates had put forward. Galen expanded upon the idea of the 4 humors and noted that black bile in a specific area actually turned out to be a cause of cancer. In his further studies, Galen described tumors, these cancerous masses that he called onkos, which is the Greek word for swelling. Throughout time, the term onkos actually continued to be associated with cancer, as the modern term for the study of tumors and cancer is called oncology, which you may have heard of before. Centuries later, the first simple treatments for cancer were put forward by a Scottish surgeon named John Hunter in around the mid-1700s. As the, quote, founder of scientific surgery, John Hunter made it his goal in life to have, quote, no less than a total understanding of life. Which, I mean, yeah, don't we all? To be fair, he actually did come pretty close to that. John Hunter really did it all. I mean, he studied teeth transplants, gunshot wounds, He had a ginormous anatomical collection. On cancer, however, Hunter had determined that all that was necessary was to determine if the nearby tissue was affected by the cancer, and if so, if removing it had no larger irreparable implications, then to do so. That simple. As simple and mundane as that treatment was, it was really the foundation of cancer treatment all the way up until the 20th century. And through the end of the 20th century and through the rise of the 21st, we would continue to do surgery while adding on other treatments such as medications, x-rays, you know, all of that. And so that brings, you've moved again. Where'd you move like that again? I'm taking away your PS2 privileges. That pisses me off. Anyway, that pretty much brings us up to today. What are the modern treatments being used to treat cancer today? Well, cancer treatment really comes down to three main therapies. Number one, hormonal therapy, in which hormones are blocked or removed in order to stop the spread of cancerous cells. The second is radiation therapy, in which x-rays are actually used to destroy cancerous cells. And finally, what you've probably heard of before, chemotherapy, which uses the treatment to change or alter the DNA within the cancerous cells to ultimately either kill or change them to stop the spread of these cancer cells within the body. But most importantly, the one this video is about, the main character of our story, the newest therapy, immunotherapy. See, with modern science and new understandings of our own biology, treatments have been developed and discovered that mimic different natural signals that are used for cell growth. Some of these immunotherapeutic agents can be created in the lab and are administered to influence or imitate natural immune responses. So basically using the immune system in the body. But why do we actually need immunotherapy? This is a very important thing to understand. Why weren't the other three therapies sufficient?
Let me explain.
Well, it's
I know why.
Why wasn't
Go ahead.
why are the
Go ahead.
previous three
No,
not
I didn't want to
sufficient?
explain it anyway.
Well, I know why. I can tell you. Well, it's important to understand that every single patient is different. Everyone requires a different range of treatments to help them in defeating cancer. Generally, they're designed in a way to target cancer cells, as their x-rays can be targeted at larger cancerous masses. However, sometimes this can leave smaller stragglers. And as for chemotherapy, well, chemotherapy is kind of a toxic drug cartel. Cocktail. Chemotherapy is a toxic drug cocktail. That was weird. Chemotherapy is a toxic drug cocktail, which can unfortunately target healthy cells on its path to destroy and eliminate cancer cells. This is why chemotherapy has a lot of common side effects, such as hair loss and... Hold on a second. Chemotherapy, hair loss, drug cartel. This is getting weird. This is why chemotherapy can have very common side effects such as hair loss, nausea, and in sometimes worst case scenarios, even immune suppression. Anyway, that was important to understand because our treatments in the modern age are not perfect in their elimination of cancer. So, I'll head out now. I really hope I didn't imagine that whole thing. I hope that whole thing was real. Now, immunotherapy can be rather specific in its function. If you remember, the goal is to spur the immune system to take out cancerous cells specifically. If it's used correctly, long-term health can be maintained. So now we can talk about pembrolizumab, but we're gonna call it Pembro. Pembro for short. Pembro. Oh my goodness. Pembro is just the drug or scientific name for Keytruda, which is the main character of our story. This is the drug that was inches from cancellation multiple times. This is the drug given special designation for its gravity-altering potential. This is the drug estimated to save millions of people, will also put a giant billion-dollar revenue in the income statement of its parent company. All of these figures are unheard of, they're unfathomable. But our immunotherapeutic superstar does the unheard of, the unfathomable, while facing the unheard of and the unfathomable. Ladies and gentlemen, this is the story of Keytruda. A story of faith, a story of failure, a story of luck, and a story of miracles.
The Minnesota Timberwolves have beaten the Lakers 4-1, and now...
And you're moving cameras. You're moved again. Okay, so we're starting part 2 on a great note. Deep breaths. He's still a goat. He's still a goat. 2 more rings. He's got 2 more rings in him. Got 2 more rings. Then it's not a question. It's not a question anymore. All right, let's get started. Whew. So our journey begins in 1923. This is the year Organon was founded as a partnership between Ernst Lacour and Sal van Zwenenberg, an endocrinologist and slaughterhouse owner, respectively. Upon inception, they sold insulin. However, they found way more success later on through the selling and manufacturing of estrogen and cortisone. In 1962, they rebranded to this Dutch word, Zwenenberg Organon, or just KZO for short, or KZO if you need a little more freedom in your life. Then they participated in their first merger. We're gonna put up a little counter somewhere on the screen, I don't know where, that counts every time Organon goes through a merger or acquisition. Because then, a few years down the line, they participated in a merger with Aku, which was a fiber producer. From there, they became AKZO, or ZO. You know, I'm gonna mix the 2 up. Then a few more years down the line, they participated in yet again another merger with a Swedish processor of chemicals and paint named Nobel. In 1994, they would go on to rebrand again and call themselves Akzo Nobel, which you've probably heard of before. As of right now, they are the 3rd largest paint manufacturer in the world. But if you look closely into Akzo Nobel, you will notice Akzo Nobel. That's because the O in Akzo Nobel stands for Organon. So that's our focus. That's where we're gonna zero in on Organon, this human pharmaceutical branch of this massive hodgepodge conglomerate of manufacturing. Then in 2003, Organon began their PD-1 research program for all antibody-related products. In a second, we're gonna get into what PD-1 actually is, but for now, just know that they were using it to initially treat autoimmune diseases. This is diseases where the body can't differentiate between harmful invaders and natural healthy body cells. This is as opposed to cancer, where the body uncontrollably creates mutated cells within the body. Are you confused yet? Well, we've thrown a lot at you, so I wouldn't be surprised. We've thrown everything from pembrolizumab, autoimmune diseases, cancer, treatments, history, whatnot, but it all comes together at Organon. That's where the story is. What were they actually studying? What was the actual science behind immunotherapy and what Organon was studying in autoimmune diseases? Well, this is very interesting, so listen up because this is important. Put the phone away, unless you're watching this on your phone. Let's talk about the PD-1 protein. This protein is located on T cells, which if you remember from high school biology, T cells are the cells within the body that kill or destroy other cells within the body that have become infected or dangerous to the body. The PD-1 protein is what's known as the checkpoint on the T cell. This checkpoint makes sure that the cell is healthy, because if it's not, well, the PD-1 protein knows this because healthy cells will produce what's called PDL1. Basically telling the T cell, hey, I'm healthy. This is where you can start to see the issue. Cancer cells will typically produce huge amounts of PDL1 to hide from the T cells. So how do we solve this? Ask the really smart guys in their smart lab coats with their glasses on. Well, you know that thing that stops killing? Why don't we take that away? Obviously not quite that simple, but something along those lines. So Organon started research on this PD-1 program to see if it was possible to use what's called checkpoint inhibitors. Remember, checkpoint means PD-1, to target cancer cells. Would it be possible to stop the PD-1 on T cells around the cancer cells so that they could attack everything and kill the cancer? Let's see. Now, 2 years after the launch of the program in 2003, 20 researchers within Organon moved to Cambridge in the United Kingdom. They would do this to continue research on the program and the research into the PD-1 protein. Unfortunately, at the time, so little was actually understood about the protein at all. Research around it was really hazy, and it was kind of questioned if anything to do with the protein would be possible at all. So after a bit of deliberation, the researchers at Cambridge made the interesting decision to go down the track of immuno-oncology, which, if you remember, oncology, study of tumors and cancer, it was immunotherapy. But the pretty major red flag within the company was that the whole thing was considered impossible. Both within the company and outside the company, there were a lot of doubt around the PD-1 protein. Reaching too far left the program sitting on the side with a grain of salt, and that would end up probably being a fraction of that grain. In 2007, Organon and the PD-1 research was acquired by Schering Plough for $14 billion. After the acquisition, Schering Plough decided to do a reprioritization of all of the assets within the company. So I've got the list here, and if you look at it, well, wow, I mean, look at that. The PD-1 research is at the top, very top. Yeah, no, this list is upside down. They were at the bottom. This is a blank piece of paper. So, you know, I don't know really where I was going with that bit, but yeah, Pembro was listed at the very bottom. So because of that, they would be given the lowest budget, the lowest amount of spending, and they would actually have very little breathing room for any mistakes at all. 2 years after that, Schering Plough merged with Merck Pharmaceuticals. It did mark the final time the PD-1 program had to go through a merger or acquisition, but this in no means meant it was the end of trouble for this company. It just got worse from there, because only a year after being acquired, Merck actually put the whole program up for sale. No joke, they actually put the whole PD-1 research program on the market for other companies to buy. And you know what was really funny? No one bought it. Merck made an attempt to sell the whole thing and no one wanted it. Unbeknownst to Merck, this failure to sell the program would actually go on to be the greatest success the company has ever seen. So just to recap, this really tiny program within a tiny company was acquired twice by massive companies, was put at the bottom of the list by one of those companies, was given very low spending, very low budget, very low everything. They were acquired by another company and then put up for sale only to be bought by literally no one. This out there research program really did start to look like a failure by all means. But that all changed in late 2010. This was when a group of scientists from Bristol Myers Squibb, commonly known under the acronym of BMS, published a report to the New England Journal of Medicine. The report showed that they were researching something very similar, and that their own drug, ipilimumab, I think. We're going with that. Commonly known as Yervoy, had very strong promise of curing metastatic melanoma, which, if you don't know, is a type of skin cancer. Now, when scientists from Organon or Merck actually read the report, it showed that their promise in curing metastatic melanoma came from something known as a checkpoint inhibitor. Where does that sound familiar? Of course, this is the same technique used in Pembro, the drug our group at Merck was experimenting with. The difference, however, is that BMS's drug used something called CTLA-4, or cytotoxic T lymphocyte protein on the T cell. Despite being different from the PD-1 protein, it's actually very closely related and can be fooled in the same way the PD-1 can be used with PD-L1. If this worked for BMS, why couldn't it work for Merck and the Pembro program? This was it. After years and years and years, it was happening. Now, by that time, Merck had actually shut down all the PD-1 and Pembro programs. But by 2011, they were up and running again, completely operational and enrolling in programs for testing and development. Heading the whole program was Eric Rubin, who had trained in oncology at the Dana-Farber Cancer Institute. It was personal, it was real, and it was exciting.
I'm closing my eyes, and if I open my eyes and this camera has moved, I don't know what I'll do.
Nah. Okay, so now we're on the right track, but If anything, we've only shown that it's possible, or at least BMS has just shown that it's possible. Can Merck actually get it done? Now, if you don't know, it takes a very, very long time to get a drug from concept to market. In order to have a successful and approved drug, it must undergo lengthy testing. The problem here lies in the fact that BMS had actually submitted their IND 6 years before Merck. BMS filed for an IND way back in 2006, when the group was still just a tiny little research group out of Cambridge. So essentially this was a race. In order to make up for the lost time, they'd have to test for very specific biomarkers, or a specific measure that captures exactly what's going on in a cell at any given moment. This meant less overall testing, but were they testing for the wrong things, this whole thing would have been entirely fruitless. Merck was essentially putting everything on red. This was a total gamble by Merck to catch up to BMS. Now, interestingly, because Merck is such a massive and established company, usually they're very conservative in their tests. But they approved the biomarkers, they approved the testing, and understood the risks they were taking. However, with any underdog story, or even success story for that matter, it's important to look at how much luck actually played a role. Because with an incredible stroke of luck, like how is this even possible? The head of non-clinical safety at Merck was a guy named Joseph DeGeorge, who was an ex-member of the FDA. DeGeorge shared a possible testing program, a BTD, otherwise known as a breakthrough destination. This could basically fast-track the entire thing with the FDA. The fact that a head executive at Merck was a long-tenured employee at the FDA was just a miracle. Without this knowledge, without this program, Pembro probably would have failed, and the biggest drug in the world would probably be Yervoy. In 2014, Pembro was approved for the breakthrough destination. Once approved, Pembro was breezing through the preliminary tests and rapidly approaching BMS. Despite the lead they previously had, it looked like Merck was catching up. While Pembro was surpassing expectations and succeeding nearly everywhere, within the company there were internal debates on what direction the program should go in. This is when Roger Perlmutter became director of Merck Research Labs. This guy was basically like the Billy Bean of cancer research. Perlmutter is the champion of the program. The success soon to be unsheathed to you is because of him, because of Perlmutter. In early 2016, the Wall Street Journal had reported that, quote, Bristol Myers Squibb has sprinted to an early lead in the race to sell a new class of cancer treatment by bucking the trend toward precision medicine. Later in the same article, the authors denote that, quote, Bristol has outflanked Merck, partly by sticking to the old mass marketing approach. Did we not just say that Merck was approaching BMS? Oh no, we did. So, Wall Street Journal was wrong. Within a year, test results had come back for Pembro and its use for first-line NSCLC immunotherapy. Whew. A lot of words, but this means that the program was testing to see if Pembro could be used as a primary medication to treat non-small cell lung cancer, a wide array of cancers covering many common varieties. For this testing, BMS had shown very poor results. They were failing to hit the very low thresholds that they had set, but Pembro remained strong in their progress. They had shown great results for their very specific biomarker research, which meant that the window for success was very small, albeit still reached. This was it. They hit red. The good old mass marketing approach seemed to be failing BMS, and Merck's calculated risks seemed to be paying off. Where to now? I don't know, but we're getting quite close to success. I knew it was gonna happen. See me? See how I don't care? I don't really care anymore. This is just beyond me getting angry. So, look, you did it again. Haha. Look, is he gonna rage out? Is he gonna get angry? See how I'm just like, I'm so removed from... Alright, I mean, listen, do what you want, do what you have to do. I don't care, because at the end of the day, I'm just giving the information. And if you want to play games like this, then I guess... Okay, so now we're just, I mean, we're definitely not using this angle, so you want to move again? No? Oh, you don't want to, okay, so we're, alright. Nope. Not getting worked up about it. Guess we're going with this angle. Are you done? Wait, hat? That's enough. Do I have to do this? Michael Jordan was a superior basketball player to LeBron James. Yeah. I said it. With nothing but positive signs coming out of these cancers, or I mean, from testing the cancer, not from the cancers, dedicated studies with very deep studies on each cancer type were initiated. Eventually this led to the advance of a way more expansive program looking into the effects of Pembro on way more advanced tumors. Now, before Perlmutter was the head of Merck Research Labs, the program was already of high importance, but once he took the reign, he considered it to be exceptional. Perlmutter admittedly said, quote, "Everyone in research, stop what you're doing now. We've got to do this." The scientists at Merck understood and put almost every ounce of effort into furthering the drug's development. Now, according to a scientist at Merck, Perlmutter reportedly said, quote, "I don't want to wake up in 5 years and wish I blew another $1 billion on this drug." And in regards to new trials and new studies, Perlmutter notably said, quote, "There is no line, do them all." It didn't take a genius to recognize something special was here. Most importantly, he recognized the value of Pembro would become vastly superior to anything else in Merck's portfolio. To Perlmutter, it was believed that, quote, "When you realize the potential of something like this, you need to bet your career on it." And so he did. Pembro was Perlmutter's crown jewel, and failure meant the end of line not only for his career, but probably for Merck's. There was a lot on the line. But hard work pays off, or so the saying goes. And for Merck and Perlmutter, it rang true. Now, between early 2016 and late 2017, Pembro officials got a call from Bert Vogelstein, who was a very renowned cancer researcher from Johns Hopkins. Or in other words, the MJ of cancer. By the way, Johns Hopkins, I always thought was because there was two guys who founded it, something Johns and something Hopkins. No, it turns out the founder was just named Johns Hopkins. Johns, it was his first name. So why is there only one of them? Now, a fellow researcher of Vogelstein's at Johns Hopkins, Suzanne Topalian, made an incredible discovery upon observing the completed study of BMS's PD-1 inhibitor drug, nivolumab, or Nivo for short. Topalian found that NSCLC and melanoma patients responded better to Nivo than other types of tumors. However, those who did react well reacted phenomenally. Geneticists in Johns Hopkins came to the realization that melanomas were associated with sunlight and NSCLC with cigarette smoke as causes. Why does this matter? They generally have higher mutational burdens. Simply put, they have more changes or mutations in their DNA than other cancers. Cancers with high mutational burdens tend to have recognizable novel antigens, substances that are easily recognized as foreign enemy cells, or mutation-associated neoantigens, which allow for T cells to create attachments way easier than normal. The issue, however, was that medical journals considered this way too wild. It was just a crazy hypothesis. So even more tests need to be done. The importance was so high that Johns Hopkins actually approached Merck to collaborate with plans and ideas on how to get them tests done. Perlmutter and Merck obliged, happily and eagerly. By 2017, papers were out proving the conjecture correct. As a result, ladies and gentlemen, the FDA approved Pembro for commercial use under the name of Keytruda. To start, it was just for a wide variety of cancers, but that number of cancers to be treated would go on to increase. This was success, this was glory, this was a revenge tour for everyone that tried to shut it down, that tried to sell it, that tried to get rid of it. For Perlmutter, this was his holy grail. In 2022, Pembro generated a revenue of approximately $20.9 billion, over 3 times the revenue of Merck's next best-selling drug, and over a third of the company's total revenue for 2022. This past year in 2024 was $29.5 billion. Numbers and money are awesome and great, but inhibiting the PD-1 protein did more than just put more money in the pockets of Wall Street. It saved, and it continues to save, the lives of millions. Without the perseverance of that small group from Oregon way back, starting in 2003, all the way up to 2017, and without the perseverance of Perlmutter and the blood, sweat, and tears and sleepless nights from him and his crew, this story ends bitterly. This was a story that really shouldn't have happened. This program was dead in the water so many times, and even when it started to climb out of that water, it continued to be in more water, if that makes sense. I don't know. It found itself in so many bad situations, and I bring it back to the beginning when I said you would think a drug of this size would be created in a super lab, when really it was just this hodgepodge team of guys putting themselves in a lab and just persevering because they saw the potential in this drug, even though literally everyone around them said this doesn't make any sense. And without all of that, if this drug, for the many reasons it could have, just ended right in the water, millions of lives would have been lost. And I think that's important and something good to end on. Ladies and gentlemen, I bet you didn't know the story of Keytruda, a miracle drug lifted up through blazing passion and an unwavering faith. Hey, so this is a story I wanted to tell for a while. This took a long time to put together, and there's a lot of great resources if you want to learn more about this story. There's a great Forbes article I will put on the screen here and link down below. All of our sources are linked with numbers corresponding to on the screen every time. Blah, blah, blah. Make sure to like and subscribe. Gosh, that felt so cringe to say that. Saying that unironically is hard. It really is. So ironically, like and subscribe, please.